We're going to look at the series from 1 to infinity of inverse tangent of n, and we want to know if this series converges or diverges. So we're going to use the test for divergence. Now this is a test you should always start whenever you get a series. You always should think about tests for divergence as the first line of attack in determining whether series converges or diverges. It's often overlooked, so you should always try it. Unless you recognize a series as a geometric series, then just go ahead and use the technique for that. But if not, use tests for divergence. It may come back inconclusive, or it may come back with a conclusion that the series diverges. Here's what test for divergence says. It says if we have a series like this, if the limit as n goes to infinity of an is not 0, then the series diverges. Now here's what the test doesn't say. It's important not to misinterpret it. It doesn't say if the limit n goes to infinity an equals 0, the series converges. That is not true. It may converge or it may diverge. The test is inconclusive if the limit is 0. If the limit is not 0, you're guaranteed that the series is going to diverge. So now let's return to our series. Our series was the summation from 1 to infinity inverse tangent of n. Now recall that the function y equals to inverse tangent of x has the following graph. We don't care about what happens for negative values of x, but we can graph the whole thing. It has two horizontal asymptotes, one right over here at pi over 2, and the second one here at minus pi over 2. And then the graph looks like this. This is y equals inverse tangent of x. Now we're interested in the values of x that are positive integers. So we plug in 1, we get the point right here. Plug in 2, we get a point here, 3 here, and so on. As you can see, the bigger the n, the closer the y coordinates of this graph are going to get to pi over 2, and so that is the limit. The limit is inherited from the continuous function. We can now say that the limit as n goes to infinity of inverse tangent of n is equal to pi over 2. Well, pi over 2 is not 0. Since this limit is not 0, the conclusion that we can draw is that this series diverges. We can now safely say that the series from 1 to infinity inverse tangent of n diverges by the test for divergence. For more videos, visit www.mathprepvideos.com.